everyone. This is the overview of the O-scope lab equipment continued. I need to go over briefly the function generator and how you use it with the oscilloscope to generate AC signals. So let's get started. Okay, this is the function generator. Okay, the output comes out of here into this coaxial cable, and it gets plugged into the oscilloscope over here of the channel of your choice, channel 1 or channel 2. Okay, so the coaxial cable basically, as you know, is a cable with a wire in the center, and then there's a metal shield around the outside of it, and in between the shield and the central wire is some dielectric material. Okay, so essentially the signal, the voltage that you're looking at on the oscilloscope, comes in through the central wire, and the shield is held at 0 volts, which would be ground. Okay, so if you were to measure the resistance between the shield and all the metal parts on the oscilloscope, you will find that they're all connected together. So, and this ground is also connected to the ground on your outlet cable, which is connected to the ground at the power plant. So that's the reference for 0 volts everywhere. Okay, now let's look at the function generator. Okay, the function generator, this particular one, has the ability to generate 3 types of functions. Okay, right now I'm generating a sine wave by pushing that button right there. Okay, and you can see that I have a nice sine wave on the oscilloscope right now. Okay, if I push this button, I get a sawtooth wave. There is a sawtooth wave. It's basically just a voltage that ramps up and ramps back down and ramps up again. Okay, and here is the other one is a square wave. Okay, by pushing that button, I get a square wave. And this square wave is not very good, so let me increase the frequency so it looks a little bit better. Okay, there we are. There is there's a square wave for you. Okay, basically the square wave just has a constant signal, then it drops to the negative constant signal, then goes up to the positive constant signal and drops down, and it repeats itself in a periodic fashion. Okay, all right, so let's look at some other knobs here. Okay, first one is the amplitude knob. The amplitude knob basically increases and controls the amplitude of the signal. So by moving that knob up and down, you can increase or decrease the voltage to your desired value. Okay. All right. So let's just leave that alone. Okay. Looks like we'll put it right about there. Okay. And then the other knobs that are of interest are the frequency control knobs. Okay, so this is the frequency control knob. Okay, the number that's on this knob is multiplied by whatever multiplier is selected. So at the top right here, you see all of these buttons right here. They go from 1, 10, 100, 1,000, 10,000, 100,000, and 1 million. Those are multipliers. It multiplies the value that's on this knob. Okay, so when we turn this knob right here, whatever value is on that gets multiplied by the multiplier. So right now I have this on 10,000. So you can see if I increase or decrease the knob left or right, I can increase or decrease the frequency. Increasing the frequency decreases the period, okay, increasing the frequency, or decreasing the frequency increases the period, okay? So if I want to measure this, this period, again, okay, I want to measure this, I just have to count the number of squares horizontally by the for one complete waveform. So I got 1, 2, 3, 4, 5. So here's one complete waveform, starts and stops right here, okay? And then it repeats itself, but I only need one, okay? Now I'm going to so I have 5 squares, and I need to find out what the time per square is. And it looks like the time per square is 20 microseconds, okay? So 20 microseconds, I got my calculator out now, okay? 20 microseconds is 20 to the -6 power, okay? And I got 5 squares, so I'm going to multiply that by 5, and I get basically 1/10 of a millisecond. 0.0001 seconds is the period for that waveform, okay, or the width of that waveform. So if I invert that, okay, I'll get the frequency. So 1 divided by that number, okay, 1 divided by that number gives me 10,000 hertz, okay, and that's exactly what I have this set on right now. I have the 10K button pushed, and the frequency control knob is set on approximately 1, okay? So 1 times 10K is 10,000 hertz, okay? So essentially, that is all you need to know about the function generator for today, all right? So I'm going to sign off now, and then we are going to continue with the lab.